Okay, so we shall start now. Good evening. So,
Good evening.
what we are going to discuss today is fluid mechanics. So, you have heard about this fluid. So, first, when you discuss about fluid mechanics, so my sound is clear and audible, no?
Yes.
No issues. Okay. So,
Yes, sir.
Yes.
okay. So, when I start with fluid mechanics, first, so actually I have written here fluid mechanics for mechanical engineering. Okay. But this fluid has almost application in what? Civil engineering, also electrical. Then but when it comes to chemical, okay, etc. When it's an automobile also, there are fluids. Okay. So this applications, the application of fluids comes in many branches of engineering. Okay. So actually, so when you discuss about fluid mechanics, okay, so what do you mean by fluid mechanics? So it deals with the behavior of fluids. Fluids can be, what are fluids first? Okay, fluids can be, what is the fluid first? It can be liquid. So water is a fluid. Okay, no? Oil is a fluid. Okay, is it clear? So first it is a liquid. Then whether gas is a fluid?
No.
Yeah, gas is also a fluid. Okay, so it deals with the behavior of liquids as well as gas. Okay, so that is what we when you discuss about fluid. Okay, so fluid is the so fluid mechanics deals with the behavior of fluids. In fluids, what are there? Liquids are there, gases are there. So we will be mainly dealing with the properties of liquids as well as gas. So what are the properties? Viscosity will be there, then density will be there. So these are the main. So I will explain what is viscosity, density, etc. But basically, when you understand about fluid mechanics, the basic thing what you have to understand is it is the branch of mechanics which deals with the properties of fluids. These fluids can be liquid as well as gas. That is what the basic explanation of fluid mechanics. Okay, so the important thing what you have to study in this fluid mechanics is the properties of fluids. Okay, so also there are two cases. Fluid can be in at rest. Okay, fluid can be at motion. Okay, so there are two cases when you consider fluid rest means if a water is at rest. Okay, if a water is kept in a reservoir, it comes under fluid at rest. But when a water is flowing through the dam, what happens? Water is in a motion. Okay, so the basically fluid mechanics deals with two cases. One is fluid at rest and another one is fluid at motion. But basically what we consider here is the first thing what we are going to study is what are the fluid properties. That is the first thing what we are going to discuss. What are the fluid properties when you consider a fluid, or what are the fluid properties in a fluid mechanics chapter. Okay, that is what we are going to consider. So next thing what we are going to study is objectives. Okay, these are the main, these are the explanations of what are things that we are going to study. Objective is shear stress in a moving fluid, difference between liquid and gas of Newtonian and non-Newtonian fluid. So we will explain what is that. Then engineering units are there, fluid properties, vapor pressure, engineering significance of vapor pressure, surface tension, capillarity. These are the things what we are going to discuss in the next slide, upcoming slide. So first thing what I have discussed in the first slide introduction, that is fluid mechanics. So it is a study of behavior of fluids at rest. So when it's at rest, we call it what? Fluid statics. And when it is in motion, we will discuss it as fluid dynamics. Okay. So fluid mechanics is a study of behavior of fluids either at rest, that is fluid statics, or in motion, which is known as fluid dynamics. So actually, when you consider fluid mechanics, the main fundamental laws which consider is continuity of mass and energy, force, momentum. What is energy equation? Energy can either be created or be destroyed, but it can be changed from one form to another. This is what basically when it comes to fluid also, the properties. Okay, then an understanding of properties and behavior of fluid at rest and in motion is of great importance in engineering. So why it has importance? Because the motion, the property of fluid. So we have seen that now in our engine, what we are using? Oil. Okay, this oil, engine oil, will be having what? Viscosity. Okay, so viscosity, it is based on the viscosity we are using the oil. So oil is a fluid. So what is the property what we are considering? It is viscosity. So basically the property of fluid has importance in the engineering. Okay, that is the basic thing you have to study. So the basic study of properties is very important when you consider about fluid. Okay, that is very important criteria. So what are the objectives? Identify the units for basic quantities of time, length, force, and mass. Properly set up the equation to ensure consistency of units. Define the basic fluid properties. Identify the relation between specific gravity, density, and solve the relationship. That is what we are going to discuss now. So first thing is, yes, any doubt? Okay. So definition is a fluid. So far, when we are going to study what is definition of a fluid. Okay, a fluid is a substance which deforms continuously or flows when subjected to shearing force. Okay, so what do you mean by shear force? What do you mean by shear force? Do you know shear force? What is tensile force? I have taught you most before the classes. So if there is a substance like this and we are applying force,
Elongation.
opposite direction. Okay, so this type of force is known as what? Tensile force. Do you remember this? Tensile.
Yes.
Similarly, if there is a force like this, and if you are applying the force in the opposite direction, so what type of force? Compressive force will be there. Okay, and so if there is a case like this, okay, and we are applying a force over here. So what type of force will be here? Shear force will be there. So the property of this substance is to shear off from this area. Okay. So you may heard about shear force, shear crack. Have you seen shear cracks? You might have seen these shear cracks, shear cracks. Do you know what you mean by shear crack? So if you are living in a flat or houses or in your houses, you may see some cracks like this in the walls. Okay. In big buildings, in big buildings, we can see this one, this type of crack. Okay, these types of cracks happen due to shear crack. These type of cracks are known as shear cracks. Okay, these are happening due to that variation in shear force in that building, etc. Okay, so what do you mean by fluid substance? So fluid, when you define a fluid definition is based on what? Shearing. Okay, a fluid is a substance which deforms continuously or flows when subjected to shearing force. Because why shear force is important? Now, fluid will be a layer material only. Okay, so they will be moving. One layer of fluid, another layer of fluid will be above that, another layer will be above that. Like that, there will be a layer of components. So the main force acting there will be shear force. Okay, if the shear force is acting on the fluid, it will flow, and if the fluid is rest, if it is at rest, there is no shear force. But when it is moving, why? Because it will be continuously moving layer by layer only. Okay, so each layer, if there is a layer in the undermost side, and if we are naming it as 1, and the topmost next layer, the layer next to it is 2, then when you see 1 and 2, there will be a force in between 1 and 2. And when you consider 2 and 3, there will be another force. 3 and 4, there will be another force. So the main tendency of fluid to flow is due to shear force. That you have to understand. The main reason for fluid to flow is shear force. So you have to understand, if the fluid is at rest, means there will not be any shear force. That's an important criteria. If fluid is at rest, means there will not be any shear stress. But if fluid is in motion, you have to understand there will be shear stress. Okay, that is the difference. If fluid is rest means shear stress is not there. But if a fluid is in motion, there will be shear stress. Okay, the concept is clear for you, no?
Yes.
Okay, so Sorry, let me run this one. So you have to understand that. So the basic criteria or basic definition what I have told is, if there is a fluid, you have to understand that it is a layer by layer thing. Okay, if this is the first layer and it's the second layer, when they are flowing, there will be a shear force between 1 and 2. When it consider 2 and 3, there will be shear stress. 3 and 4, there will be shear stress. So the main reason for fluid to flow is what? Shear stress. So you have to understand that when the fluid is flowing, there will be shear stress, and when the fluid is at rest, there will not be any shear stress. So that is what when you define a fluid. Just wait, got stuck. Wait 1 minute. Next is shear stress of a moving fluid. Okay, here we are considering the shear stress. Okay. Okay. If a fluid is in motion, shear stress are developed if the particle of the fluid move relative to each other. So, adjacent particles have different velocities, causing the shape of the fluid to become distorted. That means you can see a layer of fluid is there. Okay. And another layer of fluid is there. Okay. So what happens? There will be a fixed surface. Okay, there will be a fluid particle over here. So this layer will be having a velocity, and this layer will be having a velocity. Okay, so shear stress is developed when the particles of the fluid move relative to each other. Adjacent particles, so the particle over here and here will be having different velocities. Okay, causing the shape of the fluid to be distorted. Okay, you may see that the fluid flow. You may see, you have heard about fluid flow. So when you see a beach, how the flow is there, it will be like this, no? That is wavy form only. Okay, so when you see other rivers, etc., the flow will be somewhat parallel. Okay, but when you see some rivers, what happens? There will be some uh, flow, that wavy flow also there. So the flow the flow can be defined as laminar flow. Laminar flow means layer by layer flow. That is known as laminar flow. And also another type of flow is turbulent flow. Turbulent flow means this type of wavy forms. Okay. So laminar flow means what happens? Layer by layer flow is known as laminar flow. And when the flow is little bit wavy, it is known as turbulent. Okay. So if the fluid is in motion, shear stress are developed if the particles of the fluid move relative to each other. Adjacent particles have different velocities, causing the shape of the fluid to be distorted. Okay. On the other hand, the velocity of the fluid is same at every point. No shear stress will be produced and the fluid will be. So if that velocity of the fluid is same at every point, then what happens? The fluid is at rest. If the velocity is different at different points, what happens? The fluid is in motion, and what will develop? Shear stress will develop. You have to understand that shear stress will develop. Okay, so you have to understand there are two types of flow. One is laminar flow and another one is turbulent flow. Laminar flow means layer by layer. Okay, so it will be moving in a layer. We can see a silent river flowing, which will be a layer by layer flow. But when it is a, for example, if what happens if some calamities happen, the water will be coming at high velocity. Okay, so that you can name it as a turbulent flow. What is the specialty? It will be coming with high force and it has the capable to take away anything. Okay, that is what we when you consider about laminar flow and turbulent flow. Laminar flow means layer by layer flow. That can also be dangerous, but turbulent flow means it will be having high velocity when you consider about laminar flow. Okay. Next is, I have told you, there are two types of fluids. One is liquid and another one is gases. So liquid means, difference between liquid and gases means, liquid means we cannot compress. But what is the specialty of gas?
Yes, we can
Can we
compress.
compress the gas?
We compress.
Yes. So where you can see this compressed gas, it's there in our house itself. What is that? LPG.
Compress.
LPG. LPG is a compressed gas. No? Okay.
LPG, yes.
LPG is a fluid also. Okay. It is a liquefied petroleum gas, but what is specialty? We can compress it. But if it's a liquid, it is difficult to compress. Okay. So actually, the liquid is considered as a incompressible fluid only. Okay. Basically, it is very difficult to compress a liquid. Okay. Gases means we can compress it. Okay. Changes of volume is large, cannot normally be neglected and related to temperature. So when you compress it, what happens? The compressed gas is very dangerous. Okay. If there is a change in temperature, it can explode or it can produce some negative effect. Okay. But when you consider fluid, we will not compress the fluid. Compression of fluid is very difficult. Okay. Then occupies a fixed volume and will take place the shape of the container. Okay. So what is the specialty of a fluid? If you are filling a fluid in a bottle, the shape of the fluid will be that bottle only. Okay, no, that is what. Okay, so it occupies the fixed volume. So whatever is the volume, it will be the shape of the material what we will be using. But in a gas, what is the specialty? We can compress it in different shapes. Okay, you can say different types of cylinders. Okay, there are 15 kg cylinders are there, small cylinders are there. So it is based on the how we compress that, or what is the material what we are using. Based on that, you can produce, you can shape the cylinder. You can see that CNG cylinder is different, no? Compressed natural gas. Now the new fuel which is arriving in the petroleum pumps is CNG. CNG powered engines are now a trend now. So when you see that, not now, it was already there, but now what they have started producing engines with the CNG. So CNG is also a compressed natural gas. Okay. Then next is liquid. A free surface is formed if the volume of container is greater than the liquid. Okay. So if the volume of container is high, if you are having a 1 liter bottle and if you are purchasing only a 700 ml of petrol in that bottle, what happens? 300 ml will be a free space. Yeah, clear now? That is one. If you are having a liquid bottle of 1 liter and we are purchasing only 700 ml, 300 ml will be free space. Okay. But if it's a gas, what happens? The gas will fill all the space. No? Okay. Okay, that is the specialty. So completely fill the vessel so that no free surface is formed. So that is the basic difference between liquid and gases. So when you consider liquid, difficult to compress and often it is regarded as incompressible, occupies a fixed volume and will take place the shape of the container. A free surface is formed if the volume of the container is greater than the liquid. Gases easily to compress, changes the volume is large, cannot normally be neglected and are related to temperature. No fixed volume, it changes the volume to the expand to fill the container vessel, completely fill the vessel so that no free surface is formed. That is the difference between liquid and solids. So before going to this Newtonian and non-Newtonian fluid, I will explain you some basic things. Okay, so that is important over here. What do you mean by density? Have you heard of density? Density is always, you have to understand that mass by volume is the definition of density. Okay, density is mass by volume. Okay, then you have to study about weight density. Weight density is weight of fluid divided by volume of fluid. This is weight density. So actually, these are the basic things. So when you say about fluid, the main criteria what we say is density. So density is mass by volume. For example, when you are going to fill a petrol in a petrol pump, okay, you may see that the density will be there in one column. Okay, if you have not noticed this, when you go to pump, you can notice that. Okay, so you may see it will be 746, sometimes 748, sometimes 750 like that. density. Okay, so density is mass by volume. Mass is always represented in kilogram. Kilogram per meter cube will be its volume. Oh, sorry, unit. Kilogram per meter cube. So this value you can see in petrol pumps. Okay, so actually the concept is that if it is above 740, the petrol is good. Like that, it's the concept. Okay, so some you can see some of the people will be saying that it is below 740, etc. like that. But when you see in almost all the pumps, the density will be a standard value, or it will be in a higher range only. Okay, so you can see. So that is petroleum. When you purchase this petroleum sodium products, you can see this density. So why I am saying this example is that you can notice these things. The importance. What is the importance of this fluid in our day-to-day life? Okay, so we have studied now about petrol, then diesel is a fluid, then LPG. So water, the electricity, what we are produced is from the water. So it is also a fluid. Okay, so the properties of fluid are utilized throughout the country. Not in India, in abroad or every place, what happens, this energy is utilized for producing some outputs. Okay, its output may be electricity, some may be running an engine, some may be running turbines, etc. So it is a very important criteria when you consider fluid. So the main criteria of fluid is density. So density is actually, how can you define density? Basically, density is mass by volume. That is the definition. Density is mass by volume. Okay. Next is fluid. So fluid, there are two types of fluid. One is Newtonian fluid and another one is non-Newtonian fluid. Okay, so the first thing what we have to study is Newtonian fluid. So how this name came is Newtonian, you can say Newtonian fluid. Okay. So Newtonian fluid, how this name comes is that Newton's law of viscosity. The fluid which obeys Newton's law of viscosity is known as Newtonian fluid. Okay, so what is the importance of Newtonian fluid? If it's a Newtonian fluid, it should obey Newton's law of viscosity. Okay, so what? So next important thing is what we mean by Newton's law of viscosity. So if a fluid is a Newtonian fluid, it should obey what? Newton's law of viscosity. It is very important. So the examples of Newtonian fluid are air, water, oil, gasoline, alcohol, kerosene, benzene, glycerin. These are the examples of Newtonian fluid. Okay, so these are basically very important Newtonian fluid. So Newtonian fluid means which obeys Newton's law of viscosity. Okay. Then next thing what you are going to study is what is Newton's law of viscosity. So when you say about Newton's law of viscosity, this tau represents shear stress. Okay. First, I will represent what is this. Okay. Mu is viscosity. Du by dy is the velocity gradient. Okay. So these are the things what we are going to study. Okay. Then what do you mean by Newton's law of viscosity? Okay. So what do you mean by Newton's law of viscosity? Can anybody define? Newton's law of viscosity states that within a fluid, shear stress is directly proportional to the rate of change of shear strain. Rate of shear strain, shear rate, that is du by dy, or rate of change of strain, or this is also known as velocity gradient. Okay, so what does the Newton's law of viscosity suggest? That tau is directly proportional to rate of change of strain or velocity gradient. Velocity gradient means du by dy. Okay, u is the velocity and y is the distance where it is moved. Okay, so tau is directly proportional to dou u by dou y. So in order to remove this direct proportionality, we will be adding a constant. That constant is mu, that is du by dy. And this mu is known as viscosity. Okay. So this mu is known as its viscosity. So what do you mean by viscosity? I have told you viscosity. Viscosity is nothing but, just wait. I'll wrap this one, otherwise I cannot write. Okay, so next thing what we are going to study is viscosity. So what do you mean by viscosity? Viscosity is nothing but the resistance offered by the fluid, okay, by one layer of fluid to another layer. This is known as viscosity. Okay, viscosity is defined as the property of the fluid which offers the resistance to movement of one layer to the adjacent layer. So if there is one layer of fluid and another layer of fluid, okay, this will be moving. So this layer will offer a resistance to movement of this layer. This is known as its viscosity. Okay. So viscosity is a property of a fluid which offers the resistance of flow of one layer of fluid to another. So if two layers are forming, this layer will offer a resistance to the flow of another layer. So this resistance is known as its viscosity. Okay. So that means if an oil is thick, okay, so if you see a thick oil, what is the specialty? So if the oil is thick, it will be flowing with high viscosity. So its flow will be very less. Okay, that is a specialty. So when we are having a thick oil on the engine part, okay, it will take time to engine oil to come to all the parts, but it is thick only. Okay, so this thick oil will be having viscosity. Okay, but if it is a water, what happens? It will flow more easily when compared to oil. Okay, do you understand the concept? If it is water, what happens? It will flow easily when you consider about an oil. Okay, so oil will be having more viscosity when you consider with water. Okay, I think the concept is clear. So the viscosity is a function only if the condition of the fluid, particularly at its temperature. Okay, if the temperature increases, what happens? If the oil is at high temperature, what happens? It will become less viscous. Okay, it will become less thicker. Okay, the magnitude of velocity gradient has no effect on magnitude of mu. Okay, so that is a specialty of this fluid. So viscosity is a very important criteria when you consider a fluid property. So non-Newtonian fluid means fluid which do not obey. I have written here. The fluid which do not obey Newton's law of viscosity are known as non-Newtonian fluid. Okay. The viscosity of non-Newtonian fluid is depend on the velocity gradient as well as the condition of the fluid. Okay. Newtonian fluid means a linear relationship between shear stress and velocity gradient. The slope is constant and viscosity is constant. Okay. So the slope of the curves for non-Newtonian fluid varies. Okay. So if it is a, if you consider, if you draw a slope, this is the slope of a Newtonian fluid. It will be having slope. Okay, but if it is non-Newtonian fluid, shape can be like this, like this, like this, etc. We cannot say, we will not be able to say it will be linear. Okay, but when it is a Newtonian fluid, the shape will be a linear shape with a slope value. Okay, although there will be viscosity and the viscosity will be constant. I think the concept is clear for you. So you may see here. So you may see shear stress and rate of, that means we are discussing about tau is directly proportional to dou u by dou y. Okay. So we will be drawing a graph between tau and rate of train. So always tau will be in the y-axis and du by dy will be in the x-axis. Okay. So if it is a linear shape, what type of fluid is there? Newtonian fluid. Okay. These types of fluids are non-Newtonian fluids only. There are so many types of fluid. An example for, can you, so I have several times discussed about this Newtonian fluid. Okay, but nobody has asked me, can you give an example of non-Newtonian fluid? So there is a non-Newtonian fluid which you are seeing in everyday life. Okay, can you name that fluid? Non-Newtonian fluid. Toothpaste is a non-Newtonian fluid. Toothpaste, what you are using, it's a fluid only. Why? Because when you are pressing the tube, it will be coming out. The shape is, when you can argue that the shape is solid like, but it is not solid, it's a thick fluid only. Why? Because fluid, it is moving. Okay, so when you are applying a force, there is a shear stress. That is why it is coming out of the tube and you are using it in the toothbrush. Okay, that is an example for non-Newtonian fluid. Another example for non-Newtonian fluid, the paint. Paint is a, what we are using, the paints. Paints are non-Newtonian fluids. Okay, then clay. Clay is a non, you may say clay as a solid, it's a clay is a fluid, it is not a solid. Why? Because it is having some water content and it can, clay can also move. No, so clay is a non-Newtonian fluid. Milk, cement, etc. There are so many things. Limestone, what you say, limestone, quicksand. Okay, so there are so many examples. What I remembered, I have told you. So we can consider non-Newtonian fluids. In that, one type of fluid is Bingham plastic. Okay, there are so many categories of fluid. Okay, so Bingham plastic means resist small shear stress but flow easily under large shear stress. That is cleavage sludge, toothpaste, jellies. So if you apply a force, it will move. No, if you apply a force in the toothpaste, it will move. If you apply more force, what happens? More amount will come out. Okay, so that is comes under Bingham plastic. Then pseudoplastic is there. Most non-Newtonian fluids fall under this group. So most of the non-Newtonian fluids are pseudoplastic. Okay, an example is actually when you consider toothpaste, etc. The great example or the best example for this non-Newtonian fluid is clay. Okay, clay, milk, and cement are the best examples for non-Newtonian fluid. Okay, clay, milk, and cement are the best examples for non-Newtonian fluid. Okay, and another type is quicksand, that is limestone, what you say. Well, they are not dilatants. Okay, quicksand, etc. So there are so many applications when you consider or when you discuss about fluids. I think you have got some idea about why we are studying about this fluid in the basic engineering part. Okay, there are so many things what application comes under civil engineering, mechanical engineering, chemical engineering, electrical engineering, etc. There is an importance of fluid. That is why we are discussing this fluid part over there. I think the concept is clear and you have got some examples or some idea about these things. Okay. So actually you have to discuss some units. Actually, this is important when you consider about fluid. Okay. So what is the unit of length? Always basic unit. So you know what is SI unit? System International Unit, SI unit. Length in meter, mass in kilogram, time in seconds. Okay, temperature in Kelvin, current in ampere. Okay, luminous intensity in candela. Okay, these are the basic SI units over here. SI units means system in international unit. There are other types of units. Do you know MKS unit? Mass kilogram second. This unit was converted into SI unit with some modification. Already it was MKS units. Okay. CGS unit was there. This was the first type of unit. CGS unit means centimeter, gram, second. So length will be represented in centimeter, mass in gram, and time in seconds. But actually now what we are representing everything. Whatever mass we are saying, it will be in kilogram only, no? So now this is the standard what we follow, kilogram. And whatever length it is standard, we are representing in meter. Then whatever time is there, we are representing it in seconds. Okay. Sorry. So these are the things what comes even here. So length is always represented in meter, mass in kilogram, time in second, temperature in Kelvin, current in ampere, luminous intensity in candle. Okay. So what is how you are representing in Kelvin? Do you know? Whatever temperature. If it is 10 degrees Celsius, how will you represent 273 plus 10 will be the 283 Kelvin. Okay. If it is 20 degrees Celsius, you have to add 273 plus 20. You will get the Kelvin value. So 273.16 is the standard value what we use in Kelvin. Okay. So 0 degrees Celsius is what? 273.16 Kelvin. Okay. If it is 1 degree, it is 273.16 plus 1. If it is 2 degree, 273.16 plus 2. If it is 10 degree, 273.16 plus 10. If it is 20, 273.16 plus 20. Okay, no? So then there are some derived units. Why these are known as derived units? So earlier we have studied some units, so mass, kilogram, etc. Mass in kilogram, time in seconds, length in meter, etc. So these are derived from that units, basic units. Derived units, derived units are derived from the basic units. That is why it is known as derived units. So velocity is an example. Velocity meter per second. Okay, meter per second is meter per second. That is velocity is meter means length by time or distance by time. You basically say distance by time. So velocity is distance unit is meter and time unit is okay. Acceleration is what? Velocity by time. So velocity unit is what? Meter per second. Also one more second will come. So it will be meter per okay. Then force. Represent it mass into acceleration. Force mass into acceleration.
കലം എന്ത് ഇല്ലേ കഴുകാൻ കിടക്കും രണ്ട് കലം
Okay. Force is mass into acceleration. Mass is kilogram. Acceleration is meter per second square. So it is known as Newton. Okay. Just 1 minute. So this is the value force will be Newton kilogram meter per second square. Joule is the another unit. What is joule? Joule will be Newton meter. Newton meter. What is the unit Newton? Newton unit is kilogram meter per second square into meter. So it will be kilogram meter square plus second square. That will be the unit of joule. Joule will be the unit of energy. Power. Power is watt.
Watt.
Watt. Power unit is watt. Our electrical power. Horsepower. Horsepower, vehicle horsepower, etc. are represented in watt. Okay. Then pressure, whatever unit of pressure is in Pascal. Okay. Density, I have told you mass by volume. Mass unit is kilogram. Volume is meter cube. So it is represented as kilogram per meter cube. Specific weight is Newton per meter cube. That is the unit. Relative density. Relative density means we are relation. Relative means density of a liquid to density of a standard liquid. So both are density. So is there any unit will be there? No. Okay. I will explain. I'll wrap this one, otherwise I cannot write. So when it comes to density. Density is relative density means density of liquid divided by density of standard liquid. Okay, so both are density. So what is the unit of density? Kilogram per meter cube divided by kilogram per meter cube itself. So both will cancel out. So the unit of relative density will be, it will not be having any unit. So these type of quantities are known as dimensionless quantities. Okay, type of quantities are known as dimensionless quantities. Viscosity, the unit will be Newton second per meter square. How? Newton second per meter. What was our equation? Tau is direct. Tau is equal to mu into du by dy. Okay. So what is the unit of mu? Is equal to tau divided by du by dy will come. Okay. How? So tau is what? Shear stress unit is Newton per meter square. Okay. Shear stress is what? Force by area. Force unit is Newton per meter square will come. Okay. Then dou u by dou y is in S. So it will come upwards. So it will be Newton second per meter square. That is what? Kilogram per meter per second will come. Okay. Surface tension, the unit will be Newton per meter or kilogram per second square. Okay. Please wait. Some disturbance is there. Wait.
Hello, there is a voice
Just wait.
going on background. We can't hear you.
Any? Okay. Sorry, in between some disturbance came. Sorry. So viscosity unit is Newton second per meter square. Similarly, surface tension is Newton per meter. So these are the basic units when it comes to fluid mechanics. Okay. So I will solve a basic example to understand how it is coming. So you are given with a mass of 80 kg and acceleration of 10 meter per second square. You can find force. So what's the equation of force? Force is equal to ma, mass into acceleration. So what is the value of mass? 80. Acceleration is 10. Okay. So what is the unit? Kilogram for mass and acceleration Newton per meter square. Okay. Sorry, acceleration meter square per second. Sorry, meter per second square. Sorry, meter per second square. Okay. Let's wait. Sorry. So F is equal to ma, mass is 80 kg and acceleration is 10 meter per second square. So it will be 800 kilogram meter per second square. What is this kilogram meter per second square? What was our earlier table? What is that? It was Newton. So what will be the value? 800 Newton. Is it clear? So force is always represented by Newton. Okay. I think the concept is clear, no?
Yes.
Next, you are going to study about some fluid properties. Okay, in between, I will discuss that also. Let me run this one. you may see first is specific weight. Specific weight. What is that? Weight of fluid divided by volume of fluid. This is the explanation of specific weight. Weight of fluid divided by volume of fluid. What is weight? Weight is mass of fluid into acceleration of fluid divided by volume of fluid. Okay. What is acceleration due to gravity? Here for fluid G. What is G value acceleration due to gravity? 9.81 meter per second. Okay. So W is equal to what is weight? Mg. This is standard equation what you study, no? What is G value over here? G is 9.81 meter per second. That's the basic equation what you said. So weight of the fluid, we can write it as mass into mg divided by v, volume of fluid. Okay. So what is mass by volume? Density. We have already studied. So rho into g will give you specific weight. Okay. Density is mass by volume. From here you can take mass by volume together. It will be rho into g will give you the specific weight. Okay. Okay. Concept is clear, no? Next concept is specific volume. Okay, I will use another. Okay, next is specific volume. Specific volume. That is volume of fluid divided by mass of fluid. Okay, so specific volume is volume of fluid divided by mass of fluid. So what is mass by volume? Is density. So volume by mass will be 1 by. Is it clear? Okay, so specific volume will be 1 by rho, because if you take 1 divided by, you can write it as mass of fluid divided by volume of fluid. It is same as volume of fluid divided by mass of fluid. Both are same, no? So you can write it as 1 by rho. Okay, no? I think the concept is clear. 1 by rho. Next thing, what you are going to study is specific gravity. Specific gravity. Specific gravity is nothing but weight density of liquid divided by weight density of standard liquid. Weight density of standard liquid. Okay. So weight density of liquid divided by weight density of standard liquid. So if you are considering, how you will consider specific gravity? So what is your, if you are considering liquid, okay, if you are considering liquid, all of you please listen, if you are considering liquid, the standard liquid will be water. So weight density of liquid divided by weight density of water. If you are considering liquid, the standard liquid will be water. Okay. Similarly, if you are considering gas, okay, I have told you fluid can be liquid as well as gas. If you are considering gas, the standard liquid will be air. Okay, is it clear? So what is specific gravity of a liquid means weight density of liquid divided by weight density of standard liquid. Similarly, specific gravity of gas will be weight density of gas divided by weight density of air. In that air, we will be using as standard liquid. Okay, for weight density of water will be 1000 into 9.81. Weight density, I have told you, mass into mg. So 1000 into 9.81. Okay. Also density, you may see mercury. Mercury is 13.6 into 1000. Okay. Mercury, specific gravity is 13.6. Okay. Now, we have discussed some basic things about this fluid. Okay. I think what I have discussed is clear, no? With examples I have mentioned you. I think what I have mentioned, I have discussed in this class is concept is clear, no? If you have any doubt regarding this process, you can ask me. Otherwise, I can conclude with some explanation. Okay. Any doubt in any part? So I think there is no response from your part, so I think it's clear. So we have discussed about fluid, properties of fluid. In that, main property of fluid is viscosity. Okay, so viscosity, we have studied Newton's law of viscosity, which states that tau is directly proportional to rate of strain or velocity gradient, which is dou u by dou y. So when you remove that proportionality, you will get equal to sign, and to remove that we use constant known as mu, and mu is known as viscosity, and viscosity has very good importance in the flow of fluid. Okay, viscosity, what do you mean by viscosity? It is the resistance offered by the fluid during flow. That is what viscosity represents. Okay, it is the resistance offered by the fluid during flow. Okay, so you may see that there are so many fluids. I explained water is a fluid, clay is a fluid, milk is a fluid. The grease what you are using is also a fluid. Okay, but it is viscous and thick. Okay, motion is very less. Okay, similarly, clay, cement, etc. We have discussed all these criteria during this thing. Then we have considered what are fluids, what are Newtonian fluids, etc. What we mean by Newtonian fluid, non-Newtonian fluid, and we have derived a relation between shear stress and rate of shear. And we have got there for a Newtonian fluid, the line will be a straight line with slope, etc. For non-Newtonian fluid, it will be curves or line, but curve, and some lines will be also there. But you can say this line is, it will not be starting from the end point. You may see here, it is not starting from your origin. Okay. So Newtonian fluid will be starting from your origin, but it is not starting from your origin. So it does not obey Newton's law of viscosity. Okay. So there are so many examples for non-Newtonian fluids. So I have told you the basic examples are colloidal substances like as clay, milk, and cement are the best examples for non-Newtonian fluids, also known as pseudoplastics. And there are some other fluids known as Bingham plastic, that toothpaste what we use, the jellies what we see in hotels or in bakeries, etc. Then sewage sludge that we find over there, every time comes under Bingham plastics, and also quicksand is and also dielectric. Okay, these are the basic how you will be dividing the fluid or concept of the fluid. Also, then we have studied about units. There are primary units, that is length in meter, mass in kilogram, time in seconds, temperature in Kelvin, current in ambient, and luminosity in candela. So after that, there are some units derived from the primary units. These are known as derived units because they are derived from the primary units. So we have studied about that units also. Okay, so that is, we have studied velocity, acceleration, force, energy, power, pressure, density, specific weight, relative density, viscosity, surface tension, etc. are the derived units. Okay, I think these are the concepts what we discussed today. Okay, so 9. Okay, the time is already 9:30. Okay, so I think the concept what I have gone through is clear, no? Okay. So
Sir.
yes. In doubt? So okay, so we shall conclude. Okay, I think the concept is clear. Okay, we shall continue from the next class through some of the concepts. Okay.